All right, we're looking at Geometry Chapter 2. Chapter 2 talks a lot about like the laws of logic and different things like that, theorems and proofs, and the idea of why is something a math fact? Like, how do we know that it to be true? So starting up, we have a conditional statement. So a conditional statement is a logical statement that has two parts. It has a hypothesis, which we're normally going to call P, and a conclusion, which is normally called Q. When a conditional statement is written in if-then form, the if part contains the hypothesis, and the then part contains the conclusion. And we normally would read this out loud as if P then Q, but for shorthand, we write P arrow Q, right? A negation, right? Negation, negative, opposite, those are kind of similar words there. The negation of a statement is the opposite of the original statement. So we have some kind of statement P, the opposite of it is not P. Or here it should be a little squiggly line with a P. Maybe I can write it down better. Squiggly line with a P. You can see it down there. So that is a conditional. A conditional statement is if P, then Q. Based off that conditional, we have some other like follow-up statements that we can make. So we start off with if P then Q. The converse is the backwards version, if Q then P. The inverse is the negation of the conditional statement. So not P implies not Q. Then the contrapositive is not Q implies not B. So it's kind of like a mix of both of those. Right? That one kind of contains both of them. All right, so I know that's a lot of words. Let's look at the things that we need. We need to know what a conditional statement is. We need to know the word negation. We need to know the words converse, inverse, and contrapositive. Right. Also, hypothesis is a good word. Conclusion is a good word. And then if-then form. That's also something that we should know. All right, scrolling on. A conditional statement and its contrapositive are either both true or both false. The converse and the inverse of a conditional statement are either both true or both false. In general, when two statements are both true or both false, they are called equivalent statements. We'll have some examples of that later on. A factoid that we have is if two lines intersect to form a right angle, then they are perpendicular, right? Perpendicular. And then there's a symbol here that goes along with it, and it's like an upside down T with a little right angle marking. The little right angle marking doesn't have to be there. It could just be like this, but I will almost always write it with it there because I think that makes more sense. So, our last piece. When a conditional statement and its converse are both true, you can write them as a single biconditional statement. A biconditional statement is a statement that contains the phrase if and only if. So that's something that could be read backwards or forwards. So like if x equals 5, then 2x equals 10, right? That's an if-then. We could write that backwards. If 2x equals 10, then x equals 5. Right? That makes sense both ways. Because both of these are statements, we could combine them to say one biconditional. We would say x equals 5 if and only if, which is normally abbreviated to IFF, that if and only if. X equals 5 if and only if 2x equals 10. Right? That would be the biconditional statement. Yeah, so there we are. So if we started off with this being the conditional statement, okay, if we start that off being the conditional statement, if we look up here, this bottom piece would actually be the converse. Okay, the converse means that you kind of read it backwards, right? You swap the if and you swap the then. Now, that still leaves us with two other ones, the inverse and the contrapositive, and we'll look at those in a little bit, okay? But there we have the conditional statement and its converse, and then right here, this is the biconditional. Something to note, something to see. We normally start off with an if, and then later on we have a comma, and then we have a then. The biconditional does not have the if at the beginning and the then. Okay, it just goes right into it, and then it has that if and only if in the middle there. And then also another thing, biconditionals, you can write them either way. It doesn't matter. I could have said 2x equals 10 if and only if x equals 5. And that might actually read a little bit nicer, but they would mean the exact same thing. So let's look down here. Identify the hypothesis and the conclusion, then write the conditional statement in if-then form. All right. So right here we have this statement, and this is like two parts. So here's like part A, here's part B. All members of the soccer team have practice today. So we have this have practice today. That's kind of like what happens. Right here we have the statement like if someone is a member of the soccer team. So this would be like our hypothesis. This would be our conclusion. But if we're going to write it in if-then form, I would say something along the lines of if you are a member of the soccer team, then you have practice. All right. If you are a member of the soccer team, then you have practice today. Right, there we are. That is the if-then form. All right. Next up, now this one's written kind of odd, but we go based off of what's written first. That's the hypothesis. Actually, you know what? I just misspoke. We have to read this. X is greater than 5 if x is greater than 3. All right, I started to read that backwards. I started to read the beginning, but it's saying that this first piece is true if the second piece is true, right? So you kind of have to look at the second piece and then you go to the first. So here I'm going to say if x is greater than 3, then x is greater than 5. All right, I know that's not true, right? That's not true. But that's the way that reads to me, right? If you had written this the other way, if you had written if x is greater than 5, then x is greater than 3, I wouldn't be upset about that. That's the way that I had started off thinking it, but to me, the orange one makes more sense, right? Because it kind of in that statement, it says to look at the second guy, and that tells you if the first guy is true or false. But right here, we're getting to our first piece where it's obviously not true, right? A conditional statement can have a truth value, right? The truth value is true or false, right? Is this a true statement or is this a false statement? If we look here, this top guy, this guy is false, right? If x is greater than 3, then x is greater than 5. What if x equals 4? Right? That would obviously be false. This other guy, this guy's true. If x is greater than 5, maybe like x equals 6, then x is greater than 3, right? That's a true statement. So it's neat to think about that as a true and a false statement. And we'll have more later on where we actually need to assign a truth value. And we'll think about that later. All right, that was example 1. Example 2, write the negation, right? The negation is like the opposite. So first up, the car is blue. The car is not blue, right? The opposite of it being blue, it's not it being red, it's just it not being blue. And then it is not snowing would be it is snowing. Okay, that would be the opposite of that. Let's look next. Example 3, let P be you are in New York City, and Q be you are in the United States. Write the conditional, the converse, the inverse, and the contrapositive. All right, so let's go ahead and write here conditional. and that is P implies Q. Converse is Q implies P. The inverse is not P implies not Q. And then the contrapositive is not Q implies not P. All right. I am taking those symbols from up here. All right. So we have our original guy right here. Then we swap them. And then we go back to our original, making them negated. And then we combine the second two. So that's how I get these. And this is how I really think about them. I don't want to have to write out the whole word. I'm just going to write this. So right here, P implies Q. P is if, but we start off with if. All of these are going to start off with if. And then it's you are in, I'll just say NYC for New York City. Then what's the then? You are in the United States. So you are in, and I'm just going to say USA. All right, just kind of to abbreviate it. P implies Q. If you are in New York City, then you are in the United States. That's a true statement, right? That's a true statement. Let's look at the next one. We're going to write it backwards. If you are in USA, then you are in New York City. All right, and then we want to think about, is that true or is that false? If you're in the United States, then you're in New York City. That is a false statement, right? Right now I'm recording this video and I'm in Southern Illinois, right? We go to Murfreesboro High School. We're not in New York, but we're in the United States. So this is a false statement here. All right, let's look at the next one. Not P implies not Q. So I'm going to go back to my original statement right here, and I'm just going to put the word not. So it's going to start off with, if you are not in New York City. Let me write them down. If you are not in NYC, then you are not in USA. Maybe I can write that a little bit better. USA. All right, is that true or false? If you are not in New York City, then you are not in the United States. Let me scooch this over just a little bit because I feel like I didn't write this very well. Oops. There we go. That's a little bit better. That's a false statement. If you are not in New York City, then you are not in the United States, right? You could be in California. California is not New York City, but you are in the United States. That's a false statement. Something to note right here, these two guys match up. That's a big deal, okay? The converse and the inverse. Converse and inverse. Their truth value will be the same. All right, last one. Not Q implies not P. So we go back to our original one, and we're going to swap their spots, and we're also going to add the word nots. So if you are not in USA, then you are not in NYC. That's a true statement, right? If you're not in the United States, then you can't be in New York, right? Because we said that if you're in New York, then you're in the United States. So this is a true statement here. We should be able to see now that the top and the bottom go together, right? This is the regular conditional and the contrapositive. So the conditional and the contrapositive, they go together, okay? Now, it might be that all of them are true or all of them are false, but we know that the converse and the inverse will always be either true or false together. And then the conditional and the contrapositive will always be either true or false together. All right, let's look at example 4 here. Decide whether each statement about the diagram is true, and then it says that we want to explain. So the measure of angle AEB is 90 degrees. So we're going to say true. It is a right angle. Right, AEB, that's a right angle right there because they've got the right angle marking. AC and D are collinear. Well, that's a false statement. Right, and we could write there, they're not on the same line, right? That's what it means to be collinear. I'm just going to leave it as false right there. Ray AC and CA are opposite rays. Well, that's also false. Opposite rays have to have the same endpoint. So you'd have to have one going this way and then one going that way. Right, so that's a false statement as well. All right, scrolling down to example 5 here. Rewrite the definition of complementary angles as a biconditional, right? Biconditional means use the if and only if. So here, I'm going to take my beginning and take my end, and I'm just going to cancel out the if and the then, and I'm going to put IFF. So let's read it as this, and maybe we don't have to rewrite the whole thing. Two angles are complementary angles if and only if the sum of their measures is 90 degrees. Now that sounds about right. So there we are. We're going to cross off the if, cross off the then, and we add the IFF in there. Okay? I'm not going to rewrite the whole thing. I'm just going to leave it as that. Next up. The truth value of a statement is either true or false. We talked about that just a little bit. You can determine the conditions under which a conditional statement is true by using a truth table. So example 6 says construct a truth table for the statement if P then Q. So we're going to have P and Q. Now, this statement there, we could have P being true and then Q being true. We could have P being true and Q being false. And then we could have false and true, and then false and false. All right, that right there is our truth table. Now let's think about which ones are okay and which ones don't really make sense. So P is in the first spot, if P. If we said that this statement right here is a true statement, right? If it was true, then these different scenarios, right? We have 4 different scenarios, 1, 2, 3, and 4. Some of those would have to be true, right? Thinking about the top one. Top one is if true, then true. That one makes sense. Okay, if I tell you the truth, then later on the truth, right? If P, then Q, if true, then true. Next up, if true, then false. That does not make sense, right? If we're talking about a true statement, then that can't happen. You can't start off with the truth and end with a lie. It just doesn't work out. Now, these last two, they're kind of interesting because you start off with false statements. Now, false statements, if you start off with a falsehood, you can't really draw any conclusions, right? You think about, say you know somebody or some acquaintance, and they're just always lying all the time, they're lying. You know, everything they say, they're lying. You know, every once in a while, they might say a true statement, right? Right here, they said a true statement. But you really can't take them at their word because they said the lie in the beginning, right? You just can't take them at their word. That's kind of the way that I think about this, okay? That false going to true, that's okay, because false, you can't conclude really anything from it. It can be true or false. So that there is our truth table, and we want to think about how that second line there, that one wouldn't work out if this was a true statement. So that's that. Next up, we want to think about this one, and this one's going to be a much longer truth table. So we're going to start off as before with P and Q, but then we're going to want to try to work our way all the way over to this thing here. And we don't want to do too much jumping around in the middle, if that makes sense. So we start off with P and Q, then we'll say not P and not Q. We'll get their truth values. And then next up, we can say not P implies not Q. And then we'll have not P implies not Q. All right. Now, our first two columns there are the same as the columns up here, right? These are the only four examples that we could have with a singular if P, then Q. So we'll have true, true, false, false, true, false, true, false. All right, those are all of our scenarios. Now, looking at each column now, not P. Well, not P, that's just the opposite of what P had. So this will be false, false, true, true. And then next up, we have the opposite of Q. So this will be false, true, false, true. Now, we want to look at our next one. Not P implies not true. And this one is a little bit different than our statements up here. And you know what? I didn't actually finish this problem now, did I? I did not see that at all. P implies Q. We didn't finish that one. Let's stop and let's look up here. True going to true, we said that's okay. Right here, we said that one is not okay. That orange thing is not okay. And then we said our last two were okay. So I forgot to write those down. We talked about it, but I didn't write them down. Looking down here now, if P or if not P, then not Q. So this first column, false going to false, oh, that's all right. You know, that's kind of weird, but that is okay, right? It's okay false going to false. Next up, it's okay false going to true. That's also okay. Now, true going to false, that is not okay. And then true going to true, that's okay as well, right? To do these, I'm looking at these there, right? I'm trying to decide if it works out or if it doesn't work out. Now, lastly, this piece is just this, and then we have a negation out front, so we're just going to list the opposite of what was there. So false, false, true, and then false. And that's how we do our table. Now, I get the tables are kind of weird; they're kind of different, but I do want us to try to work them out. Okay, they're not that crazy. Just make sure you do each little piece all on their own. Again, I think it's really neat to think about how that true go into a false. That doesn't work out, right? If something is always true and then somehow it's true and then later on it pointed you in the wrong direction, that doesn't make sense, right? If something is true, right? If something is true, it's going to point you in the right direction, right? True, true. It can't point you in the wrong direction, right? You can't start off with something that's a truth and have it point you in the wrong direction, right? That wouldn't work out. All right, so that is section 1 there.